Okay, so we have the notes for section 6.5, graphs of polar equations. So polar curves are special cases of parametric curves. So x is equal to some function of theta times the cosine. Y is equal to some function of theta times the sine. And typically we stay in one full rotation, 0 radian to 2 pi radian. Now you can test for symmetry for polar graphs. So if you want to take about the x, about the y, about the origin, you're going to replace your original r's and theta with some variation on these. Typically the ones on the left will be easier to use. So here you have a x-axis symmetry, so it's mirrored top to bottom. Here you have a y-axis symmetry mirrored right to left. Here you have the origin symmetry mirrored about the origin, so 180-degree rotation. All right, so example proof that r equals 4 sine 3 theta is symmetric about the y-axis. Okay, so we're going to place our r with r. No, it's about the x-axis. Is there a typo in that? No, let's see here. Symmetrical about the y. Oh, sorry, that's the wrong one. Y-axis. This rule. So we're going to place. So we're going to write our equation as negative r equals 4 sine 3 times negative, theta. So negative r equals 4 sine negative theta. Now the sine function itself is odd, which means this negative sign can come out front. So it'll look like this, and then negatives cancel out. So we get back to where we originally are. So it is symmetric about the y-axis. Because plugging in the y-axis point gives me the original equation back. Okay, so analyzing polar graphs. The graphs of the most interesting polar functions fit within bounded viewing window that contains the pole. The distance from the pole for such a function that is absolute value of r is bounded. Known maximum value is helping in finding a good graphing window. So find the maximum value of r equals 2 plus 2 cos theta. Use it to find appropriate viewing window. So if you want to find the maximum value, you essentially let the trig function take its largest value. So in this case, the largest value that cosine can be is 1. So r would be at most, would be this, which is 4. So there you go. So 4 by 4 would be the best, 8 by 8, because you have to go out 4 units. So that's 4 units right and 4 units left. So if I was going to graph this, 1, 2, 3, 4, 5, 6, 7, 8. No, 4 by. From negative 4 to positive 4 in both directions. So total of 8 units wide. But that window would enclose all of the graph. Now you might want to go out to negative 5 and 5 on both directions just to make sure you have a little bit of room and your graph doesn't go to the edge, but there we go. All right, find the maximum r value and use it to find a appropriate viewing window. So similar thing again. So once again, the largest value the cosine can take is 1. So the biggest this is going to be is 3 times 1 or just 3. So I need to be from 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Remember, r is measured from the origin, so 3 units in all directions. So going from negative 3 to positive 3 would work. Okay. Rose curves, the graph for the polar equations, r equals a cos n theta and r equals a n sine theta, where n is an integer greater than 1, so not just theta, referred to as rose curves. If n is odd, there are n petals. If n is even, there are 2 n petals. So analyze the graph of the rose curve, r equals 2 sine 4 theta. So let's see here. So pretty much what you're looking at here is that your petals will be 2 units long. N is even, so there will be 8 petals total. And let me see if I can get my graph. Oops, go back to radian. Menu, graph. I want to switch it to polar mode, so type r equals. And then we'll do 2 sine 4 theta. And I'll try this. There we go. And so there is my rows. You count the petals. 1, 2, 3, 4, 5, 6, 7, 8. 8 petals. Okay. So graphs of rows curves. So the domain's all reals. The range goes from negative absolute value A to positive absolute value A. It's continuous, symmetric. If n is even, it's a symmetric about x, y, and the origin. If n is odd, cos theta is symmetric, so on and so forth. Here's all your definitions. Number of petals is the most important part. If n is odd, there's odd. So 3 theta would have 3 petals. Okay, the other type you have is referred to as a limacon. Limacon curves are graph of polar equation in the form r equals a plus or minus b sine theta, r equals a plus or minus b cos theta, where both a and b are more than 0. So if a divided by b is less than 1, you get this nice inner loop. If a is over b is equal to 1, you get a cardioid, and that just has a dent, so it looks like a heart, cardiac cardioid. If a over b is between 1 and 2, you get this lovely dimpled one. And if you get a over b is greater than or equal to 2, you kind of get more of a flattened look inside. So analyze a graph of r equals 3 minus 3 sine theta. So this one will be a cardioid because a and b are the same value. So it'll have a dent like that. It'll be at most 6 units from the center. 3 plus 3. If I look at my graph, whoops, 3 minus 3 sine theta, draw. So can't really see it, but it crosses here the x-axis at 3 and 3, and if you could see all the way down, it'll go all the way down to 6 units from the center. So there's where it crosses at 6. So this one, a over b is equal to 2 over 3. So this will be a limacon at most 5 units from the center, because 2 plus 3 is 5. If I look at the graph, 2 plus 3 cos theta. Oops. View window, initial. So there's your loop. The difference between the numbers tells you how big the loop is. The difference between 2 and 3 is 1, so that loop is 1 unit long. The whole thing is 2, and at most I go up 3 units. It's a lot easier to see if you look at the graph. So here's your definitions for the limacons. So the 2 things. Domain all reals, the range goes from the difference to the sum. Symmetry, depending on which one you have, which axis you're symmetrical about. Sine is symmetrical about the y-axis, meaning that it will loop down or up will be the big hump. Cosine is about the x, so right or left. Okay, so cosine will tend to always do something like, oops, shoot, came the wrong way about that. So cosine will be that long ways left, right. Sine will be, whoops, it's going to do the same one. Long way up, down. Remember, sine is y-axis direction, so up, down. That's why they're left, right, up, down. Okay, maximum r value is the sum of the 2 numbers. All right, other polar curves, r equals theta. This guy is referred to as a spiral of Archimedes. So because it just draws, because as theta gets bigger, so does r. So essentially just spirals out like this forever. Lemon skates are the graph where you have r squared equals a squared cos 2 theta or 2 sine theta. So this one, what a lemon skate looks like is an infinity loop essentially. So if you look at the graph, now this one you have to be careful of on your calculator because your calculator can't have r squared. So when you graph these on a calculator, you have to break it into 2 things. R equals the positive square root and r equals the negative, and you have to graph both of them to get both parts of the curve. So the square root of 4 cos 2 theta and negative square root 4 cos 2 theta. So there you go. Now, these Casios do not like it, but it does close in the center. So it is an infinity loop looking thing. All right, and that looks like that's the end of the section.